over the 211
Yeah, we did
homework,
go
we
over
just
211.
didn't get to go to the.
Yeah.
So we went over it already? So,
Not all of it.
Yeah.
but a lot of
Well, we went over most of
yeah.
it, 'cause
Most
that's
of
how we
it,
got our
yeah.
questions that you were gonna help us with from the packet.
In the packet, questions. If nobody has any questions off 211. Brandon, did you have questions? I know, so did you have questions off 211? Go get it in.
Yeah, I'll get it for you. On the very back, number 1.
Very back, number 1.
Pay attention. Not ready to go to the moon, dude.
What's these extra arrows tell us?
Parallel.
Those two are parallel. Did they tell us anything else was parallel? I can't really see it real well.
No.
That's all of it, isn't it? X is there. If I write something wrong, somebody please tell me. Somebody other than Thelma. She's not allowed to tell me I'm wrong anymore. 55 is there. Just look at this picture. What else do we know? So if that's 55, what's this angle?
55.
Let's put it in there. Don't know if that'll help us or not, but we'll put it in there anyway. That's basically all we can say from that, right?
Yeah.
So the next thing I would do, we got parallel lines here. You've got to separate this stuff off. You got lucky because I forgot to run off the quiz that we were supposed to take today. So we know that these two lines are parallel because we were going to take the quiz over this. These two lines are parallel, so it will be coming up. I will remember to run it off probably next class or class after sometime soon. We need one other line. What's that other line called?
Transverse.
Transversal. Good. So we need a transversal. Which line intersects the two parallel lines? Did they name these lines for us or
No.
anything? They didn't name them. So which line do we want to use as a transversal? If we're using this as a parallel, that is a parallel. What's a good transversal, you think?
The top one. The one that the X is on.
This one? So if we draw that in here, looks something like that, right?
Yeah.
Now, Brandon notices, when I'm doing this, Brandon, I'm not doing it because I enjoy drawing this stuff. I'm doing it because you just about have to do it, otherwise you can't pick out stuff in this picture. Okay? What do we know about this angle right here?
65.
Now, before I go any farther, let's just draw this over here. I got my two parallel lines. What's that line called again?
Transversal.
Transversal. Put some numbers in here. If these two lines are parallel, name me a special pair of angles that we know that we learned last time or time
Alternate
before.
interior.
Alternate interior. Alternate interior angles.
Where'd we get that?
Huh?
How'd we just get that?
Because these are the special pairs that we learned.
Like, it's
Last
just the
class.
names of the pairs.
Why did we get, how did we get?
This picture?
Yeah.
Oh, I just made up this picture so
Oh.
that we can go back over some of the angles.
Alternate exterior.
Give me a pair of alternate interior angles.
4
Four and
and
six.
6.
4 and 6. Everybody agree with that?
Yep.
Angle 4, angle 6. What's another pair?
3
3 and 5. Remember, with alternate interior angles, if I trace them, what happens? So I'm going to put that out here. Anytime you trace alternate interior angles, they form a Z. What was another pair? Alternate exterior angles. Name me a pair of alternate exterior angles. 1 and 7. Alternate exterior angles. All right, they don't form anything. Name me another pair. Corresponding angles. Name me a pair of corresponding angles. 1 and 5, I heard. Remember, with corresponding angles, how are we going to figure out which ones are corresponding angles?
Lay the lines on top together.
All right, so you smash the lines together. smash them together, and they're the angles that lay on top of each other. So 1 and 5, we said. What's another pair?
2 and 6.
2 and 6. What else?
4 and 3. There's 4 and 8.
4 and 8. 3 and 7. So on. All of these pairs that you've named so far, we know is what? They're all congruent to each other if these two lines are parallel. What's the fourth pair? Consecutive, very good. Interior angles, I say very good there because everybody all day long said it wrong. Consecutive interior angles. What's different about consecutive interior angles? Okay, they're roommates, that's one thing. And instead of being congruent, what are they?
They add up to 180.
They add up to 180, which means they are supplementary. So those are all the special pairs, and we still have angles like 8 and 6. What's true about angle 8 and angle 6?
Vertical.
The vertical angles, they have to be congruent, and you have linear pairs and all that stuff still. So look at this picture now. If this angle's 65, what can you tell me about this angle out here? 65. What's that match up to over there in our other picture? X. So what do we know about X right now?
65.
So X equals 65. Ignore that mark going up through there. So we know this is 65. Can't read that. 65 degrees.
So the angle between y and 55 has to be 65 as well, because
Those are vertical angles, right? Can we find Y?
Yeah. 65, 55.
that basically doesn't have 180.
So this angle, and this angle, all three have to add up to 180. 65 plus 55. 120. How much is left over for Y then? Is that all they asked us to find was X and Y?
Yeah.
So that's 60. What would this angle over here be? Could we find this angle up here? What do you know about the three angles of a triangle?
They add up to 180.
Add up to 180. So if that's 60, that's 65, that's 125 together, right? Subtract that from 180, what's that give us? What is it?
Is it 55?
55? Did we find every angle in that picture? Need to sink it in. Next question.
The last one on that page. Number 5.
Last one on the back page.
Would you rather work through it with us or do it alone?
Give it a learn.
Is that attitude? That's the messy part.
Are you about to try to show them all these numbers?
I Did I draw everything?
Yeah.
What line is this? Help me out.
A.
A. That's line A.
B.
That's B right here.
Yes. E.
E.
F.
F.
C. And top one D.
Tell me some numbers.
Real quick, what you're doing.
1, 2,
2, 4, 3. Where are we?
27, 28,
28.
You are not paying
It's
attention.
just that little part there.
Yeah, 29, 32,
And your grade is not that great anymore.
31,
Now get paying attention.
31.
yeah, 30,
You will not have any more computer today.
25,
Too much geometry.
26,
26.
Yep.
24,
24. 23. 19. 22, 17, which one?
Sorry.
18,
I was thinking of something else.
you're good. 15, 16, 14, 12, 11, 13, 10, 7, 6, 5, 8, and then the other one right there in between is 9. Between 8 and this.
Is that everything?
I think that's everything.
What'd they tell us? They told us,
7 equals 24 and.
they told us these two were, let's mark this first. These two were parallel, right?
Yeah.
You need to walk.
And
It's already
C and
there.
D are parallel.
these two are parallel, right?
With E and F are
And E and
parallel.
F are.
Oh, these two are parallel. How did they mark them? I got
3 of them.
So there's 3 on this one.
Yeah.
Does everybody understand that when they put more arrows on it, you gotta match them up? So we know all that. Now tell me the numbers.
7 equals 24 and 20
So,
equals 8.
so then, say it again.
7 equals 24.
7 equals 24. So this angle's 24 degrees. Okay.
And then 20 equals 80.
20 is 80 degrees. Is that all they told us?
Yeah.
Oh, that's fun.
You could probably do this, couldn't you?
I can do it.
So first thing we need to do, can't look at all this all as one thing. You got to separate stuff off. So pick me 2 parallel lines that we want to start with.
A and B.
A and B. And I'm gonna draw it off over here. Now, once we pick A and B, we gotta pick a transversal. Remember, a transversal is any line that intersects those two.
Do C.
See?
Yeah.
So this is A, that's B, that's C. This is angle 1, angle 2, angle 3, angle 4. Gotta be careful over here. We're using, this is our transversal, this is our parallel line.
5, 6, 10, and 9.
This is 5 here, isn't it?
Yeah.
But what is this angle? Is it 6?
Yeah.
It's 6 and 7.
It's 6 and 7, so can we really put anything in it?
No, I think we might want to start with C and D.
We'll go back to it. This angle is,
10. Oh, 8, 9.
that's 8, 9 together, this one's 10. So this one we really don't know either, right? Now we can write in a couple of things, like what do we know about angle 8 right here?
It's 24 degrees.
24, we can write that in. That's one of our answers in
X
here,
plus 24.
right?
For the,
Now, you could throw that in, but is that gonna confuse Tage even more if we throw an X in there for somewhere? Probably so.
Thing's not here.
So, can we really do a whole lot with this picture right now?
Not right now.
So maybe we pick something else. You can stay with the same 2 parallel lines and pick a different transversal, but you just gotta try other things. What do you wanna try?
E and F.
E and F is our parallel lines.
Yeah.
They come up like this. E, F. What are we using as our transversal?
B.
D, this one down here.
B.
Which one?
B.
This?
Yeah.
What's this angle?
6.
6, 24, which one is it? If I do E, F, and that,
6.
it's angle 6, isn't it? What's this angle? Is it just 10?
10
It's
and
10 and 7 again, isn't it? This one over here is gonna be 8 and 9 again, isn't it?
Or 8.
Or 8 and 5, I mean, sorry. And this one's gonna be 9. This would be 19, this would be 20, This is 22, 21, those I can get pretty easy. Bad thing there, again, do we know enough? What else could we pick?
C and D, and then E.
C and D? Are you guys just picking the wrong ones so that you get frustrated and quit?
Yeah.
I'm pretty sure it's A, B, and then the transversal F. That gives us the most information.
Think?
Oh,
So if I got-
none of them are actually marked.
If I got C and D, which transversal were you using? E, which goes down this way. What's this angle? Is that 24? Is that angle 7?
Angle 7.
It is this time, isn't it? So is that gonna help us? Yeah. So let's just look at that. If that angle's 24, these two are parallel. What's this angle?
24.
What's this angle? We gotta hurry. Otherwise, I'm gonna give up on this problem.
156.
What's this angle?
156.
What's this angle down here?
24.
This angle?
156.
This angle?
156.
This angle?
24.
Can we write some of those in over there?
Yeah.
We were, let's see, what we used C, D, and we used E as our transversal. Let me mark it with the black pen. That way I can erase it. So we can see which ones we have here. C, D, this is our transversal. Sorry, that's ugly. Which angle's down here at the bottom, do you know?
29, 32, 30.
29 is how much? 24. 30 is how much? 24. Now, the bad thing again, do we know 27 or 28?
No, but we do know that when combined, they make 156.
So we know from here to here is 156, right? And from here to here is 156. Same thing up here, how much is this whole thing? This whole thing?
80 and something.
Is it?
Which one? Should we use?
10 would be equal to 80 because they're a linear pair. Wouldn't it be? So it's
Would.
20 and 10 are.
Nope.
Let's pick two other lines. Thought somebody had it a second ago.
C and D with B.
Which one did you say, John? Which one did you say?
C and D with B.
John W.
I said A, B, with the transversal F.
A, B, transversal F.
And we give us the transversal.
This would be 11, 12, 13, 14. Do we know any of those?
Oh, wait, no, that'd be 15, 16, 17, 18.
Now, is it, be careful.
Yeah, 'cause we're
Oh,
at
okay,
A,
okay, yeah, I used the wrong one, didn't I? My fault, I looked at the wrong thing. That's 15, 16, 17, 18, isn't it? And then what's these down here? 23, 24, 25, 26. Do we know any of those?
Not yet. Oh, wait a minute. Did we do the, no? No, I'm not. No, because by the time that we get to A, it already would have passed through D, which is where those angles are. So those aren't actually marked angles. Like 23, 24, 25, 26.
How about if we use, let's do this. How about if we use C and D, and we use B as our transversal? that help us?
Yeah. I understand.
So C and D, what do we know about angle 20 right here?
It equals 80.
And that's this angle right here, right?
Yeah.
If we know that angle, what's this angle?
80.
What's this angle?
9.
This angle?
9.
This angle?
9.
This angle?
8.
This angle?
8.
This angle? Now, if we go back up here, I'm gonna erase some of this, so I can write in some other stuff. So we know that this one's 24, right? This one was 24.
This is a pain in the butt.
You know what, Keaton, that's what math is.
Why is it a pain in the butt though? Because you guys did what?
Pick the wrong one.
Picked the wrong thing like 4 straight times. That's what makes it harder. So if I'm looking at this, what I have right there, if I cover this up,
The same doesn't make it
angle 10 is what?
sit on the same pressure.
100.
108. Did you get it?
What do we know about angle 6 and 7 together?
80.
It's 80 together, right? That's 100. Well, if it's 80 together,
56.
put that in there.
Well, they made another one across from it too.
What's angle 9 then?
56.
What's angle 5?
100.
Supposed to be 100 there. Now, if we go back over here, can we find these angles?
It's just the same as the top one.
So angle 5's 100. What's angle 1? 100. What's angle 4?
100.
What's angle 2?
80.
Angle 3?
80. Oh, and then we can still, yeah, we can fill in 19, 22, and 21.
Let's go this way first. 'Cause I think we had that over here somewhere, didn't we? Or did we not? Maybe not. I thought we had this one over here.
We had it between 27, 28, 29, 30, 31, 32 though.
Oh wait, if we get certain numbers for E, wouldn't that mean we get the same for F if they're parallel?
So if we're looking here, let's go down like you said at first, all right? If this angle's 100, what's angle 27 down here?
100.
So it's 32. And then 28 is 56. And 31 is 56.
We know these, don't we? I didn't write them in. What's 22?
80.
80. What's 19?
100.
100. 21.
Shouldn't it be 100? Yeah, 100. My bad.
Is that right?
Yeah.
Yeah.
Where do we go to now?
Yeah, F passing through C and D. That's all we got left.
So these here is the ones that we need.
But if we figured out E and E and F are parallel, wouldn't that mean it'd be the same numbers?
Well, some of them maybe. Let's look. We look here, and you got this and this is our parallel line. Can we figure out all these?
Yeah.
What's, if this is 24, what's angle 12?
24.
What's angle 13?
24.
What's angle 14? 56. Angle 11. Now where are we gonna go to?
16, 17,
These?
We could go to the other set because it's,
The same as-
because it's the same values.
18.
So those up there are the exact same down here as down here?
Yeah.
So what's this angle?
156.
What's this angle?
24.
This angle?
156.
This angle?
24.
That's a 156.
Gee.
Now you gotta be careful. Are all these the same as these? Now on this, what we'd have to do to figure out 15, 16, 17, 18 is we need to use that as our transversal. So we have our two parallel lines, we have this coming down. How much is this angle right here?
56.
Everybody agree with that? Then if that's 56, with those two lines coming down, what's angle? That's supposed to be a 16 here, I'm guessing. What's true about those two? So this one should be 56. What should 18 be?
56.
What's 17 gonna be?
144.
15?
144.
Did we find all of them?
Hey.
And again, what's the only thing that took us so long?
These.
Once I told you which lines to pick, did everything else go fairly quickly?
Yep. Trial and error, we ought to figure it out at some point.
I'm wondering about that because Aaron gave out on me already.
Wake up!
What are you gonna do, Mr. Ebersole, IDC?
On the notes, fill in what you need to fill in on this part. Again, those two papers. You're going to turn them in. If not today, then next time.
Yep.
Some point before Thursday or Thursday. Some point before the end of the week. Please make sure these notes get into your binder where they belong.
So we turn in the packet today?
Can, yeah.
But it has to be.
It has to be in by Thursday.
Mr. Ebersole, I think so, you use yours.
I use my computer all the time when I'm thinking about this. Switch back and forth, back and forth.
Only if you're trying to teach.
Yeah, it's fine for a lot of those other teachers that have their phone. I don't, number one, I don't know how to use my phone now.
I don't even know where my phone is right now. Hopefully it's in my purse.
I don't know that
It's
my
easy
phone
to
will
switch
hold
between tabs.
All that
all the stuff.
extra crap.
Yeah. Anybody notice anything about these?
The same thing.
It's literally just the opposite of what we've already done. Like so
It switches
if
what?
and only if, so they're back and forth.
It switches what?
If one, then the other. And then
So
if
they,
the other's
they
then-
make bi-conditional
If
statements
then, right?
with what we learned before. That's what,
That's
it's
the
both
word,
words.
bi-conditional.
What's switched on them?
The order.
That's true. Tell me,
The what and the what.
Hypothesis and conclusion.
so it just switches the
I remember.
hypothesis and the conclusion. Very good. Switches the hypothesis and the conclusions. Anybody remember when we did that? What switches the hypothesis and the conclusion?
No, it's the notes.
It's the converses. So each of these is just the converse of the ones that we did before. So now, instead of them giving us a picture and telling you that these two lines are parallel, and you figuring out the angles, now what they're saying is they're gonna give you this picture, and they're gonna tell you this angle's 50 degrees, and this angle's 50 degrees, and then what can you tell them about the lines? That they are parallel to each other. Alright, so it's just going backwards.
So it's gonna be a little easier.
It,
Yeah.
which in the real world, which would be more useful? If you're out doing something that actually deals with where you need parallel lines, are you gonna know that the lines are parallel?
Consecutive interior.
Probably not. These are probably more useful than the other ones. Because more times out in the real world, are you gonna wanna know that the lines are parallel, or show that the lines are parallel, and use that fact? If I'm building something, if I'm building a deck on the back of my house, and I gotta put in the post. Those are my two corner posts I'm gonna use. What should be true about these two posts? They better be parallel. Well, the way I can check to see if they are parallel, and you've probably seen people building stuff before that have done this, they probably ran a piece of string or something across them.
Or use a level.
Now, the bad thing is if I'm building a deck,
Oh, yeah.
probably don't have a level that's like 40 or 50 feet long. You could put like a 2x4 across it if you have one long enough, and then set that on there. The bad thing with that is, what might be bad with the 2x4 if it's 30 or 40 feet long? It goes down like this. Alright, so if I take that piece of string, I can tie it across there tight. What should be true about this angle and this angle if these two are parallel?
Should be the same.
They should be the same, and that's what this first one says. If those corresponding angles are congruent, those are corresponding angles, then I know that my lines here are parallel to each other. I know that my posts are parallel to each
Gotta
other.
hope they're perpendicular too. If you're building a deck, you don't want that thing sideways.
Well, so you mean you want what?
Right angle.
You want a right angle here and a right angle here, so same idea, they have to be the same. Those angles have to be the same, they both have to be right angles. And that's all these say, every one of them. Just switch around. Last time, these were our conclusions, and we were starting off with none of the lines were parallel, now it's got them switched. On this one, all we're going to do is fill this in, draw this little picture on there. The two lines are both in a plane, so if we have these two lines, somebody name that line for me.
And
Line N, line H, and then we have this line. What's that line called?
Transversal.
Transversal, very good. We got this transversal. Line T there. If, what's that box tell us? That forms the right angle. That forms the right angle. If N is perpendicular to T and H is perpendicular to T, what's that tell us about N and H?
The parallel.
They have to be parallel. So draw this picture and put those arrows on there. They have to be parallel to each other. They have to be parallel to each other. Again, that's what we were just saying about the post. Got to be the case, all right?
straight up and down.
Now you got to be careful when you say straight up and down. Does that actually work?
Decent amount of the time.
What's wrong with the ground?
I mean, when you're looking side by side, they go one direction. There you go. Straight up and down.
You better hurry. Get your books out. Get out a clean sheet of paper. We're going to do this assignment together. You guys are going to answer questions. If you don't, then I'll just say, just turn it in now, and whatever we don't get done, counts against you.
You got an extra shoe case.
Keaton's going to help us out, right, Keaton?
Sure.
Gonna be on it.
We're usually,
I'm just marking for
You need
April.
extra. I have extras.
That was last time. We're not gonna do it. Starting to try, you know? Well, it's fine.
Landon's happy because this is one assignment for sure he'll have turned in.
don't mind,
Don't worry, I don't do it, so the rest of I do it too.
There you go, Aaron.
Should we wake yet?
I get the nipple. Paige is the local notebook dealer.
Please, please back up. Oh, yeah. You beat me to it. Did you see the recording that I did?
Yeah.
Left.
Yeah.
On to you, girl.
That's why, if you have like punched your, revenue off the table.
No, I wouldn't be mad. Go ahead.
I think he would be more mad.
Anybody have it written down? Yes, no, maybe?
Yeah.
Boy, we can't even answer that question. I have this bad feeling that we're getting ready to turn this in right now.
Yay.
No, not you.
I read it.
Number one. You have to read problems to me and stuff so I know what the problem says. Number one, what do they say? Angle 3 is congruent to angle 7. Looking at those two angles. Aaron, you still with me?
Yeah.
Looking at those two angles, what's the transversal that connects those two angles?
What's the transmission?
L. So what line do I want to get rid of in this picture?
Yeah.
If I cover that up, what kind of angles are those 3 and 7 to each other? What special pair?
Interior.
Alternate interior. Did we have a theorem that said if they're congruent, then the lines are parallel?
Wow.
Which lines are parallel then?
A and B.
That's what you write down. Line A, parallel to line B. Now to answer Chase's question from earlier, they said give a reason, correct?
Yeah.
All you're gonna do on these reasons, don't make this harder than it is, it's not that much to write. It's just gonna be one of those theorems, and it's just gonna say if, what kind of angles were those two to each other?
Parallel or alternate exterior.
Other one.
Interior.
Alternate interior angles are what to each other?
Are you
Congruent.
Congruent. Then what do we know about the lines?
I'm so bored.
Parallel.
He wears me out.
No, that's easy.
Well, why don't you go home?
And we didn't write
I
theorem
think that would be a really
3.20,
bad idea for you,
Chase.
baby.
Oh, it's Miss
Yeah.
Hammond.
It would be bad for you if she left.
Next one, what's the next part say?
Sorry.
Angle 9 is congruent to angle 11.
Angle 9, angle 11. Which line connects 9 and 11? So what line do I need to get rid of?
T. Or is that? That's an L again.
So if I get rid of that, what kind of angles are those two to each other? Corresponding angles? What two lines are going to be parallel? Line A and B again. Line A is parallel to line
B.
B. How do we know that? What kind of angles were they? So if corresponding angles are what to each other? Congruent. Then what do we know? Lines are parallel. Please don't say lines are congruent. Can lines ever be congruent?
No.
Why not?
Because they go on.
What can you not do with the line? You can't stop it, you can't measure.
Infinity.
Number 3, what's number 3 say?
Three.
Angle 2 is congruent to
2 and 16? 2, 16. Which transversal connects those?
Hey,
A. So we're gonna get rid of B. What kind of angles are 2 and 16 to each other?
alternate exterior.
Alternate exterior. What 2 lines are gonna end up being parallel?
You're,
Oh, man.
I'm covering them, right? Line L, parallel to line M. Give me a reason, I'll give you the first word. If.
If alternate exterior are congruent, then lines are, parallel.
Alternate exterior angles congruent, then line parallel.
See, I did plan somewhat.
I appreciate it. What's the next one say?
Angle 5 plus angle 12 is equal to 180.
So angle 5,
measure.
Or yeah, no.
those 2 add up to 180. Well, if they add up to 180, that means they're what kind of angles to each other?
Consecutive.
Supplementary, and they're also,
Consecutive.
is that what the theorem said? Consecutive interior angles should be supplementary?
Yeah.
Yeah.
Yes.
So what 2 lines, what transversal gives us 5 and 12? B, so what are we getting rid of?
Okay.
Getting rid of A,
Line L and M are parallel, well, line L is parallel to line M.
line L, parallel to line M. What's our reason gonna be?
Supplementary angles as seen.
Close.
Are we gonna add this to our column?
If consecutive interior angles are supplementary, then parallel lines.
Consecutive interior angles, sorry, this is hard to read. Consecutive interior angles are supplementary.
Then lines congruent.
I won't throw something.
Or not. I read the wrong part of it.
Then lines are what?
Wrong part.
Parallel.
Parallel.
I read the wrong part, my bad.
Wasn't he just making fun of somebody else for saying lines?
Yep.
A second ago?
John.
No, you asked and I gave an answer. I didn't make fun of anybody yet. No, not this time.
You know, the next person to say that, that's probably gonna get a book in their hand.
I got booked.
I'm talking math.
Couple of things that you should never say. Number 1, lines are congruent, because it's not possible. Another thing you should never say, lines are straight.
They are.
They are. There's no reason to say it. All lines are straight. If you draw this, that's not a line, it's not a crooked line, it's not a curvy line, there's no such thing.
Squiggle. It's a sine wave.
Does everybody have all those? Next one, number 7. You'll have to help me out on these because I didn't fill in the parts, and you're gonna solve them, so have out your calculators and be able to solve these real quick.
Guys,
You have to tell me which angle they tell us. So as I point at them, and you're gonna make this easier and go quicker. We should have this done in like 5 more minutes. Shouldn't take us that long. Do we know that?
No. No. 2x plus 6.
Where's the other one? Tell me the
Right
relationship.
below 130.
Right below it, right
Yeah,
here?
right there.
130? What kind of angles are these 2 angles to each other? Consecutive interior angles, so they should add up to, so what equation can I set up?
130
130 plus 2x plus 6 equals 180. Write that on your paper and solve it. Please write it on your paper so that we don't have to sit here for 5 minutes deciding that you got the wrong answer.
and I did that.
love solving equations, dude.
Yeah.
Solve for X.
Okay.
You're irritating me very bad.
Would that be?
Like, hang on a second.
What do you need to do first?
No.
Because you're not paying attention.
What do you need to do first? But we
What'd you
combine.
say? Because I don't think you said it right. What'd you say?
Where are the terms? 1 and 1, 6 and 30, right? So
Do this
that-
first, put those together. What's 130 and 60? So write that down right there. Put
So right if I show it.
2x plus 136.
Plus, what do you need to bring back? And all that stays equals what?
And that still equals what on this side?
I said wrong, but I promise I'll do that.
No, 20.
I know she does.
Now, what do you do with 136?
What do you say?
Subtract pencil sets, right? That's what you got.
Okay. Right, now what? What do you think about
See,
it?
it's 2x over here, right? 130 minus 136.
Got it. Minus 136. Good job. Alright, do you have a calculator? Yeah, would you have a calculator? 180 minus 136.
I didn't get 44. I got 26.
What'd you come up with?
22.
Anybody else get 22?
Yeah.
I got 22. Let's get that out. Okay.
What'd they ask us to find? Just x? Or did they ask us to find something else?
It said find x so that L is parallel to him.
So that's all we needed, right?
Yep.
Next one. This angle?
Nothing. 4x minus 10.
And then it'd be the
Alternate
where
exterior.
alternate exterior.
Alternate exterior, so out here?
Yeah.
Yeah.
So it'd be 3x plus 10.
And then
Good,
that's-
that's what I wanted. My other classes couldn't figure out, hey, explain it to me that way so that we can get done quicker, right? They had to go through and point at each one every time. What do we know about these angles?
They are congruent.
They should be congruent if the lines are parallel. So 4x minus 10 equals
3x plus 10.
3x plus 10. Solve that.
Divide by 2.
Yep. And then divide it by 2. So what is x equals what? Plus 4 divided by 2.
Josh, I have this feeling I'm gonna have to start taking grades for calculators again.
I was just thinking that.
So next class,
Why, do it with my head over here. You don't want me to do it with my head.
next class.
You might be right.
You didn't think I had my calculator
Next-
for a second. It's okay, I forgot
Alright,
myself.
here's my transversal. These interior,
The
exterior.
response.
Exterior, alternate exterior, are they congruent or do they have to be separate? So what needs to go between these?
I did when I had to sit here and watch over you, but if you.
Yeah, it's 'cause I'm
I'm
messed
gonna
up.
write down what you're
I wrote everything down.
Tell me what it is. Is there a equation?
So it's 3x
Alright.
plus 2
I got it.
equals 4x minus
3x plus 10 equals 4x.
Keaton's gonna make sure that
There you go.
he's actually got a calculator and not his phone.
Well, I cleaned out my backpack.
I didn't say this time.
See?
No, I'm just saying, right?
Future reference, future
Okay,
reference.
sharpen these markers.
What'd you get?
20.
20? Anybody else get that?
Yeah. Yep.
First step.
Did you hit it? You worked it out?
You wanna minus 10? Okay.
Yeah.
I don't care, you guys are wrong, they're wrong.
What do we have?
I like that.
What do we have?
Next one, number 9, help me out, let's go. Move quicker now.
Just put on the minus one.
Alternate interior. Goes up to 6.
This
No,
one?
other way.
Other way.
6x plus 4.
8x minus 8 on the other one.
subtract 3x.
Is that right?
Yep.
What do we know about
Subtract 3.
alternate interior angles?
It'll be x. It'll be x equals.
Anna.
Nope.
They make a Z.
They make a Z, that's true. What do we know about them?
They're congruent.
They should be congruent. So what's my equation?
So 6x plus 4 equals 8x minus 8, right? Minus 8.
Solve that.
Which is what? By itself.
Zero.
You're looking zero, so put a zero there.
Oh,
Now, what do we need,
keep that.
what do we need to do with that? It can't be on the same side, what do we need to do? We need X over here.
Anybody get it yet?
Or over here.
Yes.
What do we need to do?
6? Everybody agree with that?
Yeah.
Okay. What's happening with X and Y?
Same kind of problems. All they're doing is they're saying, if we want these lines to be parallel, what's X have to be? The other time they were saying, if these lines are parallel, what's X? Same thing. Next one.
Walk to the
So
exterior
what's left over
perimeter.
here?
This one?
Here,
Yeah.
20. Yep.
What is it?
4x. 4x.
An alternate exterior, so this one?
Yep, X plus 6.
What do we know about alternate exterior angles if these lines are parallel?
Good job. We'll do number 9 together.
That they're congruent.
They're congruent? So what equation?
So x plus 6 equals 4x.
Solve that.
Yeah, that's fast.
What is it?
Yeah.
2. X equals 2, everybody agrees with that?
Yep. That was quick maths.
You don't?
Yes, no, maybe? All right?
Yep.
Yep.
Next blue notes.
All right.
We'll get it.
Number 11. Which angle? This one?
Upright angle. No.
Yep.
7x plus 5.
No.
It'd be bottom, no, down, down.
One
Bring up.
X.
5x
5x
plus 19.
Plus 19?
Exteriors, but they're not alternate exteriors, are they?
What kind of angles are those?
Can we talk about this?
Course.
Can you put this in that or is it on top? Correspond. Will that smash on top of that?
And then exterior. They are exterior, but
Yeah,
they're.
well,
Will it smash on top of the correspond?
Oh.
Will it
No,
smash
Smash them on top,
the-
they're
they are
exterior,
what?
so.
the same.
Corresponding
So
angles.
what equation do we set up for that?
Corresponding angles.
Remember, corresponding means we take this line and smash it down. Does that angle go lay on top of that angle?
No.
Nope.
Are they alternate interior angles?
No.
Are they alternate exterior angles?
No.
No, would they be corresponding exterior angles?
We don't have that up here.
Consecutive.
Consecutive.
We don't have that up here either.
Well, it can be
They are
consecutive
vertical.
exterior.
So what are they to each other?
Vertical.
Nothing. Thank you, John W. They're nothing.
There's something.
Does that mean that we can't do something with it? No. What do you know about this angle and, let's see, let's say this angle?
Corresponding angles.
Those two are the same. They'd be corresponding, wouldn't they? So if this is 7x plus 5, what's this angle?
7x plus 5.
Now what can you tell me about those two angles?
Equal 180.
So they're supplementary, they add up to 180. Tell me the equation I could set up.
7x plus 5.
Let's do this. Let's make it shorter on everybody. Could we collect like terms before we write it down?
Yeah.
How many x's you got?
This here.
12x.
Plus 24. We know that those two add together should equal how much?
180.
Solve that equation.
This is for this one equal, right? So what, we'll do it this way.
Just say this number like 14 different times. 7x plus 5
Plus.
plus 5x plus 15.
Give out on me, Aaron.
No, I'm listening.
I got 13.
He's just resting his eyes. Hopefully.
These are
13.
Right, Aaron?
Okay, stay with me. What?
Dallas is laughing at you. She's usually hitting it on, waking up all the time.
Dallas sees the tables in turn.
Mr. Ebersole, nothing against you, but if I had your class in the morning, I'd be asleep.
Bro.
Yeah. You can ask Ms. Barnes.
The carbs hit us after.
You remember that, right?
You said you can ask
Every day.
Barnes.
Yeah.
What's x equal?
13.
13.
Does everybody agree with that?
Yeah.
And then what do we do with them?
I already did number 12.
Number 12, tell me the angles. Where are they at?
No way.
They're, consecutive interior.
And then we
No,
have
yeah.
Y.
This one?
So it'll be 3x plus 10.
And
Five X plus
5x
18.
plus 18.
I don't want.
What do you know about consecutive interior angles?
They add it to 180.
So what equation can I set up? Go ahead and collect like terms.
There's, 8x plus
28.
28
Equals,
180.
solve that.
Sorry, the why.
That's what I got. That's what I got 19.
So you got
What two things are bugging you?
19, everybody agree with that?
Yeah.
Yes.
Yes, no, maybe?
Yes.
Give up, you gave up again, didn't you?
I kept messing up, so no.
Yeah. I know it's 156. I would use a calculator.
You can't mess it up if you don't do it. Right, Nate?
I mean, there's no holes in that theory.
Well, 24 is just
If you don't do the work, you can't mess it up. You just can't get the number from the. I don't know, though, it's just.
You do better get them organized in 156 and then 12.
Here's what you did here. You're trying to do the math.
Well, if you
Without
go-
actually doing stuff. See if I solve it.
It doesn't matter. So I mean, anything else for that?
Subtract 28 on that
Alright,
side.
we'll just find this 156 divided by what? Okay, show your work.
I did 8. Yeah.
What comes?
Now, look at number 12.
Now what do we do?
Look, number 12.
8.
There we go.
So it's talking about these two angles here. You said they're what? Remains consecutive interior, right? So what about them? Okay. When you do what we're doing.
13. Same kind of problem?
Yep.
Yeah.
Which angles they tell us?
They're.
That one, yeah.
This one?
Mm-hmm. Yeah. 7x.
7x plus 5
7 x plus
15. And then it's the interior. Nope.
We'll solve it later.
Yep.
25.
What kind of angles are these two to each other?
They're nothing.
Nothing to each other.
They're angles on the same plane.
So that doesn't help us a whole lot.
These two.
Can we find this angle?
But,
So what do we know
yeah,
about these?
that's also, that's.
What do you know about these two?
7x.
Equal 180.
They add up to 180. So somebody find this angle for me.
7x plus 15. Because,
They add up to 180. Somebody find this angle for me.
oh, that's just 155.
155. Now, notice I was sort of ignoring Keaton. You were right. I just didn't want that. Because if we put 7x plus 15 there, 7x plus 15 equals 7x plus 15, and we try to solve that, they're going to do a whole lot for us. But now, what do we know about these two angles? They're equal, right? They're congruent. So 7x plus 15 equals what? Is that something we can solve?
Yeah.
Do it. What'd you get? Everybody agree with that?
A lot of twos.
Aaron, do you agree with that?
Yes, I do.
Number 14, really quick. They tell us this angle is 70 degrees, I believe, don't they?
Yeah.
This angle's 70 degrees.
Yeah.
When you get a picture like this, it doesn't look like our normal picture. Do this. Extend the lines on out. These two are lines that we're looking at. This is our what again? Transversal. Forget the books. Got to sort of ignore them for now. What kind of angles are these two angles to each other?
Which ones? Consecutive.
Separate it off. If you need to, come down here and redraw it just like this. This angle's 70, this angle's 70.
Yeah, consecutive internal angles.
Consecutive interior angles?
Interior, not internal.
Is that right?
Corresponding.
No.
Can't be, yeah.
Corresponding?
Corresponding.
Which one is it?
Corresponding.
If you smash the lines together, right? To be consecutive interior, both angles have to be where? They have to be roommates. They have to be on the interior. Right? So, corresponding angles. If those are corresponding angles, what should corresponding angles be? Congruent. Are they?
Yeah.
Yes.
So if they're congruent, what do we know about this book and this book?
There.
They're parallel. So our reason's going to be if corresponding angles are what to each other? Are congruent, then what do we know about the books?
Parallel.
Books are parallel. That's our reason. How do we know all that? That theorem right there.
That's a good theorem. Is it true?
Last one real quick. So apparently these people are shooting off these fireworks and they want to put 2 setups on top of the house there, and they got these 2 setups on the ground down here. And I think they say this angle is 70 degrees, don't they?
Yep, and the house is a 30 degree.
There's a 30-degree angle on the house over there. We'll get to that here in a minute because I don't want to put it in there because it's going to confuse things. We want to figure out what angle 1 is right here. So how are we going to manage that? Can we find any angles? Did they ask us to find this angle? No.
Oh, wait a minute.
Couldn't we?
All the lines are, wait.
All the lines are parallel. Could we find this angle?
Yeah.
How much is it?
110.
So let's write it in there. How much is this angle right here?
70.
How much is this angle?
110.
110. You could extend these on down if you wanted. We could find these angles over here too underneath the ground, but that's not really going to help us a whole lot. But how are we going to get that from here over? Is it going to work? Just move it up here and say, oh, well, then this is 70, that's 110. Is that going to work? No.
Wait. So so the angle of the roof, like parallel to the ground, is 30.
That's this angle. That's the pitch of the roof right here.
So would we?
What can we do with these 2 lines so that we could try to match them up with those?
Extend them out.
Very good. We extend them on out. What's this angle right here?
70.
What's this angle?
110.
70 and 110.
Now let's look at this stuff. We're looking at this. We got these 2 lines going up there. What do we know about this line and the ground?
Parallel.
We hope they're parallel, right?
Better be.
If they're not, there's something wrong with your house.
Or there's something.
So if that angle's 70, what's this angle right here?
110.
That one's 110, right? And this one right above it is 70. Now, because I'm running out of space, I can't write in that little spot. We have this little shape right here. What shape is that? Let's draw it bigger so that I can do this. You just told me this angle's 70. They told us the pitch of the roof is how much? Can we figure this angle out?
80.
3 angles of a triangle have to add up to 180. So that's, let's see, that's this angle right here.
And then okay, 100.
That's 80. So what's this angle right outside here?
100.
100. What's this angle right here then?
80.
80.
And then 100. And then
100. What's angle 1?
80 degrees.
So what's the measure of angle 1?
80.
Sometimes, a lot of times in geometry, you have to find other things. Did they ask us to find all these angles?
No.
I thought we
Was
were
there-
doing number 17 next.
Was there any way that we could have found the angle we were looking for without finding those angles?
No,
No.
no.
Set that off to the side, make sure your name's on it, get your notes back out, fill in what you need to fill in on this.
This is so much fun. It wasn't bad, so it was like slight.
No, that's not even trouble. This time.
Turn those in.
We're the bottom tray, right, Mr. Ebersole? Or not bottom, second from bottom.
Next to the bottom end.
So the bottom one.
It's the bottom one that has anything in it, not the very bottom.
So either way.
So,
Right, not either way, it's only one bottom.
I was right.
A lot of this stuff from last year you should know, so we're gonna go through it real quickly. Slope. What's another way to say the slope of a line? Rise over run. Make sure rise is telling you to do what? Go how? Up or down. Run's telling you left or right. Please don't get this confused with when I give you a point. What's the x coordinate? The first number will point
Left or
to you.
right.
Tell you to go left or right, and the y tells you to go up or down. Don't get them confused because they're backwards of each other. Right? If you have a horizontal line, I'm going to draw this out here. You might want to draw it also. You have your x and y axes. A horizontal line may look something like this. Goes side to side. The slope of that horizontal line is always zero. All right?
It's not going up. It's not
Different
going
than this slope. These are two different things. Slope 0 and no slope, two completely different things. Don't get them confused. If we have an equation, last year and we're going to talk about it here in a minute, you've seen a lot of equations that look like this. All right? If you have an equation of a horizontal line, it's always going to be y equals just some number, no x's in it. So if I had this equation, y equals 6. All you're doing to graph that line is you count from 0, 0, 1, 2, 3, 4, 5, 6, and you draw in a horizontal line. Y equals some number is just a horizontal line. If it's x equals some number, then it's going to be a vertical line. So if I have this, a vertical line is going to look something like this. I could draw a vertical line. The equation is always going to be just x equals some number. So x equals 5, no y's. X equals 12, x equals -3, whatever it is. That'd be the equation for this. If I drew a vertical and a horizontal line on the same graph, what do you know about these two lines? That's true. Give me a little more information. What kind of angle is that going to be? It's going to be a right angle. They're going to be perpendicular to each other. Every vertical and horizontal line is perpendicular. Again, the slope of a vertical line, it doesn't have a slope. Don't put 0. 0 and not having a slope, two different things. All right? Don't think that this and this are the same. You cannot mathematically figure out the slope of a vertical line
You cannot divide by 0.
because you can't divide by 0. It's mathematically impossible.
You can divide 0, but you can't divide by
Right, so this one, the slope's going to be something like 0 over 5, which is just 0. This one's going to be 5 over 0, which we can't do.
syntax errors.
Fill in what you need to fill in on this. Probably learned this last year also. What do you know about two lines if they're parallel? What's true about their slopes? They've got to be the same. So if lines are parallel, slopes are the same. The second part you probably learned, but probably didn't use it as much, so it might not have stuck with you. What's that upside down T mean again?
Oh,
Perpendicular. Forms right angles. So if two lines come together and they form right angles, their slopes are opposite reciprocals of each other.
Correct.
And what that means, first, if my arms are parallel, and I tell you the slope of my left arm is 5, what's the slope of my right arm? 5. If I tell you that my arms are perpendicular to each other, then their slopes have to be opposite reciprocals. If I give you this, 2/3, is that 2/3 positive or negative? Positive. What's the opposite of a positive?
Negative.
So we know our answer is going to be a negative.
Negative 2/3.
The reciprocal, what do you do to it?
Flip it.
You flip it over, so it becomes -3/2. These two are opposite reciprocals of each other. The other problem that a lot of students have with this, when you're doing opposite reciprocals, that number, this number, and this number,
Yeah.
all the same number. Don't treat them like they're different. All right? Those three are all the same number. Don't treat them like they're different. It doesn't make any difference where that negative's at, whether it's on the whole thing, whether it's on the top or on the bottom. Now, would it make a difference if it looked like this?
Yeah, because then it's just positive.
Then it's just positive. That's different than those three, but those three are the same, so it doesn't really matter where you put that negative. One last thing here. Fill that in. It's all stuff that you seen last year, I hope.
Starts in 8th grade.
8th grade.
She did it last year.
You know, I failed that algebra state test.
Well, don't even worry about that test. There you go.
What two things do you need to know to write an equation in slope-intercept form?
My quadrant's
What two things do you need to know?
your y-intercept.
The y-intercept and the
Slope.
slope. What two things do you need to know to write something in point-slope form?
Slope.
Slope and some point on the line. Don't make point-slope form harder than it is. Everybody hates this form. All you're doing with this, you're plugging in the x here, the y here, and the slope there. You're just plugging into that form, and then that's your equation. Don't make it harder than it is. You're just taking three numbers and plugging them in.
You have it written down?
Yeah.
Your assignment's on the last part of. So in this example, if there's two different ways that we could do this. You could just use the slope formula, which ignore that. Just subtract the y's on top, subtract the x's on bottom. Or we could graph it. I'm going to go ahead and graph it and do it both ways here real quick, then we'll do the next one, whichever way we can do the shortest. The graph n equals 3, 6, so I go to the right 3, up 1, 2, 3, 4, 5, 6, that's n. T is -9, 2, so left 1, 2, 3, 4, 5, 6, 7, 8, 9, up 2. That's T. That's our first line. H is 5, 4. And S is 2, 3, so right 2, up 3. And that's our second line. We're trying to decide if these lines are parallel, perpendicular, or neither. Don't just go by the drawing. Make sure you're actually doing what you need to do here. And what we need to do is find the slopes. If the slopes are the same, then they're parallel. If the slopes are opposite reciprocals, then they're perpendicular. If the slopes are neither one of those two things, then they're neither thing to each other. So to find the slope, I just pick these 2 points that I just graphed, and I just count rise and run. So here I go up 1. So the slope of this bottom line is up 1, and to the right 1, 2, 3. So over 3, so that means the slope of that line is 1 over 3, 1/3. Other one, I find the slope, rise, over run. Rise is 1, 2, 3, 4. Run is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They don't look the same right now, but this one, this fraction can be reduced. Remember, your calculators will reduce it for you too if you punch it in and then just use the fraction button or hit equals depending on what kind of calculator you have. Well, 4 will go into 4 once, 4 will go into 12 3 times. So that's 1/3. The slope of this one's 1/3. That tells us that these two lines are parallel to each other. Instead of graphing them, I could have used just this formula. Just remember with the formula, the y's are on top, the x's are on bottom with the slope formula. So if I do the slope of line NT, ignore that. The y's for N and T, if I look here, the y's are 6 and 2. It doesn't matter which order they go in as long as you keep the y's and the x's in the same order. So I'm going to do 6 minus 2. And since I went from here to there, when I do the x's, I'm going to start with the 3 and go that way. So 3 minus a negative 9. When you do that, that's going to change to a positive there. 6 minus 2 is 4. 3 plus 9 is 12. So that's the slope of line NT. Then if I do the slope of line HS, for H and S, the y's are 4 and 3, so 4 minus 3. And the x's are 5 and 2, so 5 minus 2. Again, the order makes a difference. When I start with the 4 here and do 4 minus 3, that means I got to start with the 5 and do 5 minus 2. With distance formula and midpoint formula, that didn't make any difference. With slope formula, it does. The order matters. 4 minus 3 is 1. 5 minus 2 is 3. Then we're going to compare these two. Again, they don't look the same right now, but if we reduce this one, that's 1/3, that's 1/3, and that tells us that these two lines are parallel to each other. So either way you do it, whether you graph it and find the slopes that way, you're just comparing the slopes, or you could use the formulas. This one, I'm just going to use the formulas. Again, you could graph it if you want. So if I do line NT, slope for NT, if it helps you again, like we did with the distance formula and the midpoint formula, go through here and you put an X there, a Y there, X there, Y there. So our X's are 14, or I'm sorry, we got to do our Y's on top. Our Y's are 13 and 0, so 13 minus 0. Then our X's would be 14 minus a negative 11. When we minus a negative, change it to plus. You end up with 13 over 14 plus 11 is 25. Then we look at the slope of line HS, ignore that. Slope. This is an X, that's a Y. This is an X, that's a Y. So the X's, I'm sorry, the Y's, I'm going to do 7 minus a negative 5. And if I went here to there, then that means for the X's, I got to go here to there. So negative 3 minus a negative 4. That's going to change the plus there. That's going to change the plus. 7 plus 5 is 12. Negative 3 plus 4 is 1. Look at these two, 12 over 1 and 13 over 25. They're not the same. So that means these lines can't be parallel. Well, they might be opposite reciprocals of each other. So if I try to figure out if they're opposite reciprocals, the opposite reciprocal of 13 over 25, it's a positive, so it'd be a negative, and we flip it over, 25 over 13. Well, that's not the same as this, so they're not opposite reciprocals of each other either. That means they are not perpendicular. Then that means the only answer we have left is that they are neither thing. So if we were to graph them, what would end up happening if we graphed them? And these numbers are pretty big, so I might not be able to graph them, but if we were to graph them, let's see, 14 and 13, negative 11. I probably don't have enough on here. If we were to graph them, let's say 14 and 13 would be out here somewhere, negative 11 and 0 might be way down here somewhere. Negative 3 and 7, so that's one of the lines. Negative 3 and 7, something like that. Negative 4, negative 5, something like this. Well, what's going to happen is these two lines are going to intersect somewhere. So they're neither parallel nor perpendicular. Find the slope of each line. To find the slope of each of these lines, all we're going to do, we're going to find line A first. If we're on a graph, just do the rise over run. So if I'm going from this point to that point, and it doesn't matter if we start at this one or this one, whichever point we start at, I'm starting at this one. So we do our rise, 1, 2, 3, 4, 5, 6. So we go up 6. Then I run 1, 2, 3, 4, 5, 6, over 6. That reduces down to 1. So the slope of line A is just 1. Slope of line B. And when I look at this, notice that line A is going up, so it should have a positive slope. Line B is going down, so when I'm done with this, it should have a negative slope. If I start here, I go up 1, 2, 1, 2, 3, 4, 5, 6. I go up 6. Then I go 1, 2, 3, 4 to the left. Well, 4 to the left is going to be a negative 4. And if I reduce that down, that's going to reduce to 3 over negative 2. Notice it has a negative slope, negative 3/2. If I look at line R next, line R is a horizontal line. If I just pick 2 points on here, maybe that point and that point, my rise is 0, my run is 1, 2. 0 divided by 2 is just 0. So the slope of that horizontal line is 0. Line Z, if I pick 2 points, it's a vertical line. If I pick 2 points on it, the rise 1, 2, 3. So I go up 3, and I go run left to right 0. Well, 3 divided by 0 you can't do. So the slope here, and I should put an equal sign there, is it has no slope. All vertical lines have no slope. Three different equations of lines. You got the slope intercept that you learned last year. You got point slope that you learned last year. You probably learned standard form last year also, all three of those. We're going to use these two more often than we use this one. And just like last year, we're probably going to use the slope intercept form more than any of the rest of them. To write an equation of a line in slope intercept form, you need to know the slope of the line, and you need to know the y-intercept. That's where it crosses the y-axis. And if you know that, if you know those two things, all you got to do is write an equation with the slope right here in front of the x and the y-intercept right here. You just stick those two numbers in there. So if we're on a graph, and we'll do some here in a second, if we're on a graph, you find those two numbers, you just stick them in there. That's the equation of your line. Most students don't like point slope. To know or to write something in point slope form, all you need is a point that's on the line and the slope of the line. So any point that's on the line. Point slope's actually an easy form. All you're going to do with point slope is you take the coordinates of the point, you got your x coordinate, you got your y coordinate, you're going to plug that x coordinate in right there, you're going to plug the y coordinate in right there, and whatever the slope is, you're going to stick in right there. So you're just taking three numbers and sticking into those three spots. Don't make that harder than it is. Standard form is used a lot in algebra. We don't use it quite as much in geometry. I will say this. If we have something in point slope form, so if they tell you, let's erase all this. They tell you a point on the line is 2, 1. That point's on the line. And the slope of the line is 3. I'm just making up something that's sort of easy. We're going to stick this 2 in place of the x right there, the 1 in place of the y right there, and the 3 in place of the m. So our equation is going to come out looking like y minus, it's always a minus, these signs are always minus, until you stick in a negative, then it's going to change to a plus. So y minus 1 equals, and then for m we stick in 3, parentheses x, and then we stick in the 2 for the other x. So that's our equation. The bad thing with this, a lot of times we don't want the equation in point slope form because nobody likes it. We'd rather it was in slope intercept form. Well, there's 2 steps to change it from point slope form to slope intercept form. And I'm going to show you the 2 steps. First thing you do is you distribute. When we distribute up here in this equation, we'll end up with y minus 1 equals 3x minus 6. Then the second thing we do, we get y alone. And the way we get y alone is by taking this number that's over here with the y and moving it to the other side. Well, if it's a negative 1 over here, then we want to add 1 to both sides. When we add 1 to both sides, the ones over on this side cancel out. We're left with just y equals the 3x stays the same. Negative 6 and a positive 1 give us negative 5. Now that equation, we switched it from this point slope form to slope intercept form, and that's the form we wanted in. So just 2 easy steps. Don't make that harder than it is. So again, to write an equation for a line, either you have to know slope and the y-intercept, or slope and some point that's on the line. And we can write an equation in one of those 2 forms, either in y equals mx plus b form, that's slope-intercept form. Again, don't get this confused. This is slope-intercept form of a linear equation. This is the slope formula. The slope formula you got to use to find this m so you can write something in slope-intercept form. And then the second one, point slope form, y minus y1 equals m times x minus x1. All we're going to do with this, plug into these 3 spots. So if you know a point, whatever that point is, and you know the slope, this is the easiest form to plug it into, then switch it over to slope intercept. If you know what m is and you know what b is, then this is the easiest form to write an equation in. So if I'm looking at each of these, we'll do line A first. We're going to write an equation for line A. Most of you like slope-intercept form better, so that's what we're gonna use on this one. All we're gonna do is find the slope and the y-intercept. The y-intercept's usually pretty easy to find because it's just where it crosses the y-axis. Point A, or line A crosses it right there, which is 1, 2, 3, 4, 5, 6, negative 6. Then to find the slope, I just do rise, overrun, up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 5, 6. So slope is 6 over 6, or just 1. And if we're going to write this in that slope-intercept form, y equals mx plus b, we're just plugging it in place of m and plugging it in place of b. So in place of m, we stick in 1. In place of b, we stick in negative 6, so it's going to be a minus 6 there. That's the equation for line A. For line B, same idea. Pretty easy to find the y-intercept, just where that line crosses the y-axis. Looks like it's right there, so that's just 1. And to find the slope, we do rise over run. Be careful when you find the slope. This line's going down, so it should have a negative slope. 1, 2, 3, 4, 5, 6. Going up 6. 1, 2, 3, 4. And over 4. Since we went to the left, that's not just a 4, it should be a negative 4. So the slope is going to be up 6. And to the left 4, that'll reduce down to 3 over negative 2. We write our equation, y equals mx plus b. In place of m, we stick in that. Y equals negative 3 halves x. Doesn't matter where the negative's at. The negative's out front here, if it's on the 2 or the top or bottom, as long as it's not on both of them, that means something different. Plus, our y-intercept was 1, so that goes in there. That's our equation. Just notice I didn't put a name on this line. We'll call it line E. So if we look at line E, find our y-intercept. Now, our line's going to cross the y-axis way up there somewhere. So I have no idea how to do that because our graph's not big enough. So let's find the slope. Slope, we go up 1, 2, 3, 4. And to the left 2, so that's a negative 2. So our slope is 4 over negative 2. That reduces to just negative 2. Now we could find the y-intercept, or we could just use one of these points and write the equation in point-slope form. And that's what I'm going to do. So if I just find this point right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we go to the right 12. Let me count it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we go down 1, 2, 3. So it's that point. 12, negative 3. Point slope form looks like this. This is our x, this is our y, this is our m, and we're just going to plug in to these 3 spots. So y minus a negative 3, which we'll change that here in a minute. M was negative 2 times x minus, our x coordinate was the 12 right there. This minus and negative here, we can just change that to a plus. So now it looks like y plus 3 equals -2 times x minus 12. Sometimes it's all right to just leave the equation in that form. Most of the time in this book, they want you to change it into slope-intercept form, so we just have to do the 2 steps. Step 1, we're going to distribute. So we end up with y plus 3 equals -2x. -2 times -12 is 24. And then we're going to do step 2, which is just get the y by itself. So we subtract 3 on both sides. These cancel out, and we're left with y equals -2x plus 21. Now that's in slope-intercept form, and that's a good equation. The other 2 lines on here, R and Z, let's do R. When we look at R is a horizontal line. All you got to do to write an equation of a horizontal line is figure out what this point right here is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it goes down 11. Since it's a horizontal line, the equation is always going to be y equals some number. So that number is just going to be what you just counted there. So y equals a -11 is the equation. Notice there's no x's in there. It's just y equals some number for a horizontal line. Same thing, same idea for z, except this time it's a vertical line. So when we write our equation for z, we just count. We just count over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we went to the right 13. And it's always just going to be x equals some number. Or that x this time is going to equal 13. So it's just that. X equals 13. Again, with a vertical line, it's always going to be x equals some number. With a horizontal line, it's always going to be y equals some number. On these, if we're graphing these lines, to graph them, just look at what you have. Our y-intercept is 3 for this first one, so that just means we go up 3 and we put a dot. Then our slope is just 3. Put a 1 underneath that so that it looks like a slope. That tells us rise over run. So it tells us go up 3 to the right 1. Up 3 to the right 1. Well, if I keep going up 3 and to the right 1, I run out of space. So the other way that you can go with that is instead of going up and to the right, you can go down and to the left. So down 3 to left 1. Down 3 to left 1. Then our line's going to look something like that. That's for number 1. Number 2, y-intercept's -2, so go down to -2. Put a dot. The slope this time, again, rise over run. This rise this time says a -3, so that's telling us to go down 3. And then the +5 is telling us to go to the right 5. And again, I'm running out of space going down this way, so the other thing I could do, instead of going down and to the right, I could go up 3 and to the left 5. And notice it falls in the same line. So that would be line 2. The next one, they tell us n is negative 4, 5, so that's just where I'm going to start. So I go to left 4 and up 5. That's n. Then the slope this time tells me to go up 3 to the right 2. Up 1, 2, 3 to the right 2. And again, I'm running out of space going that way, so the other way I could go is down 3 to left 2. Down 3 to left 2. That's line number 3. Next one, they tell us the y-intercept and the x-intercept. The y-intercept is just telling you where the line crosses the y-axis. So you just go to where y is 4 on the y-axis. 1, 2, 3, 4. That's that point right there. The x-intercept is negative 2, so we go to where x is negative 2. That'd be right there. And we just want those two, just connect those 2 points. So that would be line number 4. Don't make this one harder than it is. You're just graphing that point, and connecting them. Write an equation of each line. This time we're writing the equations of lines. They've already got one line for us. This is the line that we're starting with. But we're trying to write a line that's either parallel or perpendicular to those lines. Well, if 2 lines are parallel, we know that their slopes have to be the same. So on this one, what I'm going to do, I need to know, to write an equation for this line, I need to know the slope of the line, and I need to know either the y-intercept of the line or some point that falls on the line. Well, this time I know a point that falls on the line. So I'm actually going to write this one in that point slope form, and then we'll change it into slope intercept form. So we're going to write it in that form. This is our x, this is our y, and our slope we have to find. Well, if the 2 lines are parallel, the slopes have to be the same. So if I look at this line, the line that it's parallel to, the slope of it is right there. Then that means the slope of the new line has to be the same. So it's negative 3/4. And all I'm going to do is stick those things into these 3 spots. Our y this time, our y sub 1 is 6, so y minus 6 equals, the slope is negative 3/4, parentheses x. And then our x this time is negative 4, so it's minus a negative 4, which we're going to end up changing to positive. If nothing else, if you leave it in that form, you probably get some credit. If it says it wants it in slope intercept form, which I didn't say in my directions here, but if the book says that or the test says that, then you need to change it. And you just got to do the 2 steps. Step 1 is just going to be to distribute. And this is where most of you probably aren't going to like it, because you got to distribute out this fraction. So when we distribute there, the left side stays the same, it's just y minus 6. Then we take negative 3/4 times x. That's just negative 3/4 x, nothing hard about that. Then you take negative 3/4 times 4. If I write that down here, negative 3/4 times 4, put a 1 under the 4. And you could do this on your calculator too, maybe. Just make sure you get a fraction answer. These 4s are going to end up canceling out. You got negative 3 times 1 is negative 3 on top. And on bottom, 1 times 1 is just 1. Negative 3 over 1 is just negative 3. So all that ends up happening there, the fraction ends up going away. Then the second step, we want to get y by itself, so we just add 6 to both sides. These 6's are going to cancel out. I'm going to rewrite this over here because I'm running out of space. So you're left with just y. On the other side, you got negative 3/4 x. A negative 3 and a positive 6 give us positive 3. That's our equation in slope-intercept form. Another way you could do that same kind of problem, if you don't like this way, if you don't like dealing with the fractions, you're going to have to deal with the fraction sum, but maybe you'll like this way better. And this way is just by finding the b, which is your y-intercept. Again, if the two lines are parallel, we know the slopes are going to be the same. Well, the slope of this line is negative 3/4, so the slope of the new line's got to be negative 3/4. And what we want is we want to find the b so that we can write this in that y equals mx plus b form. The way we're going to do that is we're going to take y equals mx plus b. I got it. So I got y equals mx plus b, and all I'm going to do is I'm going to plug in for y, I'm going to plug in for m, and I'm going to plug in for x, and all that leaves me with is b all by itself, and I can mathematically figure out what b has to be. This is our x, that's our y, this is our m. So in place of y, I stick in 6. In place of m, I stick in negative 3/4. In place of x, I stick in negative 3. I don't know what b is, so what I'm trying to do is just do the math here and get b by itself. When I do this, to multiply this, ignore that, put a 1 underneath that, negative 3 on top, negative 3 times negative 3 is 9. On bottom, 4 times 1 is just 4. Again, if we're going to do it this way, then what we need to make sure that we do is our answer needs to make sense. And I'm not really going to throw a big fit about it, but if you're doing it on an EOC test or something, then you may see things that look different. So you got to know, hey, do I want to change this into a mixed number, whatever. So the 9/4 there, you could write it as 2 1/4. Or we could change the 6 into fourths and do it that way. Whichever way you decide to do it. I'm going to do it this way. I'm going to change that to 2 1/4. 9/4 is the same as 2 1/4. You're doing it on your calculator might look something like this. If you tried to change it, it might say something like 2 and then have this little thing, and then have a 1 and then a slash and a 4. Some of the calculators look that way, some of them look different. We need to subtract 2 1/4 on both sides. If we subtract 2 1/4 on both sides, we end up this way. 6 minus 2 1/4 is 3 3/4. Now the bad thing with that is that we want to change that back. So we got, so we know b is 3 3/4. I'm going to come back over here and I'm going to write this. Now, again, I'm not going to throw a big fit about which way you write it. Y equals mx plus b. But you got to know that there's different forms of this and it could be written different ways. All I'm going to do is plug in for m here and plug in for b. So you could write y equals 3/4 x plus 3 3/4. I probably wouldn't throw a fit if you changed the 3 3/4 to 3.75, but just know that that's probably not the way a math test like the EOC would be written. They would probably write it with this number as an improper fraction, and to change that back to an improper fraction, all we do is take 3 times 4. So 3, the whole number times the bottom number, then add the top number. Everything else stays the same. So it's 3 times 4 is 12, plus 3 is 15, so that ends up being 15 over 4. That's what the equation, that's probably the best mathematical form of the equation. But you gotta find the M and you gotta find the B. I'm gonna erase some of this so I can do this last one so I don't have to bend over. I'll do it up here. So ignore this, we've already done that. Write an equation of a line parallel to this line containing that point. I don't like finding the B, but that's the way most students like it. I know my sons, that's the way they always wanted to do it. I'd rather use point slope form, but I'll find the B again, so we'll find the slope and the y-intercept. We know the slope, if they're parallel, the slope has to be the same as the line that they give us. Well, that right there is the slope, so the slope of our new line has to be 1/2. To find the B, again, I'm just going to use y equals mx plus b. This is our x, this is our y, this is our m. So I'm going to plug in 1 equals 1/2 times our x is 3/2 plus the b. Do the multiplication right here. I get 1 equals 3 times 1 is 3, 2 times 2 is 4, so 3/4 plus b. I'm trying to get b by itself, so I subtract 3/4 on both sides. These cancel out. I'm left with 1/4 equals b. Ignore that, that's supposed to be a 1/4 and that's a 1/2. Then I plug back into y equals mx plus b form. I'm just going to plug in for m, plug in for b, that's going to be our equation. Y equals, the m was 1/2. The b was 1/4. That's our equation. Y equals 1/2 x plus 1/4. I know last year you got used to this b, a lot of times being a whole number. That's not going to be the case, because remember that b is your y-intercept. So when we're looking at this, it's wherever the line crosses the y-axis. Well, wherever lines cross the y-axis isn't always just going to be some whole number. So a lot of times they are going to be fractions. Write an equation of a line that's perpendicular to the given line. So this time we want perpendicular to each one instead of parallel. If they're perpendicular, then that means their slopes have to be opposite reciprocals. Opposite reciprocals. So when I find the slope of this line, the slope of this line is -2. The slope of the new line has to be the opposite reciprocal of that. So the first thing I'm going to do, ignore that, I'm going to put a 1 underneath this. So the slope of the original line is -2 over 1. I want the opposite of that, which is going to be a positive, and the reciprocal. So I flip it over, and it's going to be 1/2. Then I'm going to find the b this time, just like on the last one. This is our x, that's our y. Our slope is this right here that we just found. So y equals mx plus b. Ignore that. In place of y, I'm going to stick in 6. In place of m, I'm going to stick in 1/2. In place of x, I'm going to stick in -3. And again, if you use your calculator and you do it, and you put in 0.5 instead of 1/2, and it comes out something like this, I'm not probably going to throw a big fit. It'd be a better form if it was in a fraction form, but I probably won't be real mad. 1/2 times -3 ends up being -1.5 plus b. Then we add 1.5 to both sides. and you get 6 plus 1.5 is 7.5 equals B. So you come back over here and you say B is 7.5. You write your equation, y equals mx plus b. The m is 1/2. The b is 7.5. Ignore that part going up through there. If you write your equation that way, I'm probably not going to throw a big fit. The better form for this would be to change this into, instead of 7.5 or instead of 7.5, change it to an improper fraction. 7 times 2 is 14 plus 1 is 15. So that's 15 over 2. That would maybe be a better form. These are both the same equation, just written in two different forms. The last one here, I'm going to write this one in point slope form because, again, I like it better. But if you like finding the b, then use that. Again, we want them to be perpendicular. The slope of the original line is right there. It's 1/2. So the slope of our new line's got to be the opposite reciprocal of that. The opposite would be a negative. And then the reciprocal, we flip it over. So it'd be 2 over 1 or just -2. This is our x, this is our y, our slope is this. Y minus, I'm going to use point slope form to write an equation. We're going to plug in here, and plug in here. So we get y minus, the y coordinate is 1. The m slope is -2. The x coordinate is 3/2. Oops, sorry, that's in the wrong spot. That's x. Let's not do that. Let's erase it. This is x. X minus, then we stick in our x, which is 3/2. Again, if it helps you out, change that to 1.5. If it makes it easier for you to do, 3 over 2 is the same as 1.5. Step 1, we distribute. -2 times x is -2x. -2 times -1.5 is going to end up being a +3. Then the last step, this one worked out nice because that got rid of the fraction and got rid of the decimal also. Then we add 1 to both sides, and we end up, these cancel out, we end up with just y equals -2x stays the same. On the other side, we've got 3 plus 1, which is 4. So now that's a nice looking equation that's in slope-intercept form. That's the assignment.